All right, stats class. Let me recording round 2 here, take 2. Hopefully I will make sure that I keep this video shorter. If I need to make 2 videos, I will. So I wanted to give you some more information on the two-way ANOVA, and I'm starting here because I want you to know that you need to be able to fill in an F table for the two-way ANOVA. And so on page 374 in your book is where it gives you the formulas in each of the cells. So that's a good place to start. Again, it is very much like the one-way ANOVA, where you take sums of squared going along the rows, you do the sums squared divided by the degrees of freedom gives you the mean square. But then you need to know how to do the F's, which is always the mean square for that row over the mean square within. Okay, so when we take 1.5 divided by 0.0625, we get a F of 24, which is just a whopping huge F. Actually, all of these F's are significant here. Those are astonishingly large F's. So we would get this F by taking the mean square for arousal divided by mean square within, and we get that. So make sure that you know how to fill out, again, like the previous exam where I had some elements here missing, but you have all of the figures in order to calculate those cells. So now what I want to do then is to move forward and show you how to graph, how to make these bar charts that correspond when I give you a table like this, which are the means, right? Remembering these are the cells, which are the unique combinations of the IV and the result on the DV. And then the marginal means are those which span on the outside, which indicate only for one IV, the 2 levels, right? So these 2 are marginal means for task difficulty. These 3 down here are the marginal means for arousal. So let me go ahead and draw these. So you see that for the easy task difficulty, we have 10 at all levels of arousal. So I'm going to go ahead and draw those here, and then I will show you them. And then for the hard task difficulty, you see that they're 20 across all levels of arousal. So when I render that, you can easily probably infer here. So I'm going to, you can see that because they all look the same, right? These are identical to each other. Notice I have the dependent variable over here, which is math, and I have one IV here, which is arousal, and one IV here, which is the legend for how I render it when I only have the same color with me. You could also use different colors. So there's no interaction here. And how do we know that? Again, don't just take my word for it. But if I'm going to connect for easy task difficulty, I do this, and we can take it out just so that we see that. And for hard task difficulty, we take it out. The lines are parallel. There is no interaction. Again, this is just looking visually at whether there's an interaction, not whether I'm actually looking at the F first, right? I would need to look at the F. If the F shows that it's not significant for an interaction, then I wouldn't be doing this. But I could give you this without an F and just without the F table, right? And just say, go ahead and chart these. We aren't going to ask whether it's significant. I just want you to know, be able to chart it and tell me if, given the chart, whether there's an interaction. Next, we're going to look at another set of data with the same DVs and IV. So you notice that for easy task difficulty, low is 10, moderate is 20, and high arousal is 30. So I'm going to draw that here again. And then when we look at hard task difficulty, we find 10 for low arousal, 20 for moderate arousal, and 30 for high arousal. So to see what that visual picture looks like, that produces a bar chart like this, okay, where each one steps up gradually. So again, if I'm going to just look at task difficulty, I'm going to take this to this to this, and this to this to this. Again, they're actually identical. So they don't cross at all. And again, remember, we're looking for whether the lines cross when we connect for one IV across the other IVs. So let's look at another set of means. So here we have easy low is 10, easy moderate is 20, easy high is 30. Hard low is 10, hard moderate is 20, and hard high is 60. So that produces a bar graph like this. Okay. So I'm going to connect again for the task difficulty. So I'm going to go low to low to low. And remember, we're going to take it out. Then I'm going to go hard to hard to hard. And of course, we see here that it crosses. That means there's an interaction. So the next question becomes, what kind of interaction? Remember that a quantitative interaction is one where the relative relationship at each level of the other IV is the same, but it's either greater in quantity or lesser in quantity. Whereas qualitative means that it changes. So if we have, I'll show you one that's like that. This is a tricky one that actually I would take whether you call it a qualitative or quantitative, right? Because when you talk about equal, right? In other words, we have the same outcome on math on the low arousal, easy hard task there, same here. And here we don't have the same. So I would take it if you'd call it a qualitative or a quantitative, but I want you to be able to talk about it. So when you say it's an interaction, let's call this a qualitative interaction, such that when we have task difficulty, low and moderate arousal yields the same math, the same outcome on math. However, when we look at high arousal, those who are in the easy task group have lower math scores than those who are in the hard task group. So we see something qualitatively different there. All right, let's move forward to the next one then. So in this one, we have easy low is 10, easy moderate is 20, and easy high is 30. Hard low is 20, hard moderate is 30, and hard high is 40. Okay? So that yields a bar graph that looks like this. Okay? So you can see that, again, my drawings aren't necessarily on the scale. You can see the distance here is pretty equal, right, between these. But so if again we connect for easy, we have this and it goes out here. When we have hard, we have this and it goes out here. So again, the lines are parallel. There's no interaction on this. Okay? So what I want to demonstrate to you, though, is a qualitative interaction. So I'm actually going to do that without a set of data here. So I'm just going to have you listen to me. So let's go ahead and I'm going to write down that we're going to say that low easy is going to be 10. Moderate easy is going to be 10. And high easy is going to be 30. low hard is going to be 20. Low or moderate hard is going to be 20. And moderate hard is going to be 10. Okay, so when you look here now and we connect for the easy, it's here, here, and oops, sorry, here, here, and here, right? So we want to keep that flat. And when we connect for hard, we're going to go hard, 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 right? So again, you see that there's a line that crosses. Now, is this qualitative or quantitative? When we look here on the low arousal, we see that the easy always has lower mass scores than the high, than the hard. We see the same relationship, right? So the hard task difficulty is the highest mass score on low arousal. The hard task difficulty is the highest mass score on moderate arousal, but we see a change not on the high arousal, right? On the high arousal, we see that the easy task is the highest as compared to the hard. So this is a qualitative interaction because it's a different relationship between the one IV when we look at the level of the other IV. Okay, let me